Have you ever watched an ant trail and wondered, who's in charge here? Is there a tiny general shouting orders? Or a queen on a throne dictating every move? The answer might surprise you, and it reveals one of nature's most brilliant designs. For a long time, we've used the term hive mind to describe colonies of social insects like ants. It paints a picture of a single, unified consciousness, a superorganism where individuals are just mindless drones. But the reality is far more fascinating. Ant colonies are not controlled by a single mind. There's no central brain, no leader, no tiny command center directing the actions of every single ant. So if no one is in charge, how do they accomplish such incredible feats? How do they build complex nests, find food with incredible efficiency, and defend their territory against rivals? The secret lies in a concept called decentralized intelligence. Each ant, every single one, is an individual decision maker. They don't receive global commands from a queen or a council of elders. Instead, they operate based on local information. An ant responds to what it can see, smell, and touch in its immediate surroundings. It's a world of simple rules, not complex strategies. This is where the magic of collective intelligence comes into play. The complex, seemingly intelligent behavior of the entire colony emerges from these very simple, individual actions. Think of it like this: an ant might follow a rule as basic as if I smell a strong food pheromone trail, follow it. If the trail gets weaker, start searching randomly. No single ant has the big picture. No one knows the exact location of the food source or the best path back to the nest. But when thousands of ants follow these simple rules, the colony as a whole behaves as if it's a genius navigator, quickly establishing the most efficient route to the food. Let's talk about those chemical trails, the pheromones. These are often misunderstood as direct commands, like a tiny walk this way sign. But they're not. Pheromones are a form of information, not an order. When an ant finds food, it leaves a pheromone trail on its way back to the nest. Other ants that stumble upon this trail can read the information. They can sense its strength, which might indicate the quality or quantity of the food. But each ant still makes its own choice. It might decide the trail is too weak to be promising, or it might get distracted by a different scent from a predator and decide to retreat. The trail guides, it doesn't command. This individual choice is crucial for the colony's adaptability. Within the colony, you'll find different roles. There are workers who forage for food, soldiers with powerful mandibles for defense, and of course, the queen, whose primary job is to lay eggs. These roles seem rigid, but there's a surprising amount of flexibility. An ant isn't locked into its job for life. If the colony suddenly needs more foragers because a rich food source has been discovered, some ants that were doing nest maintenance might switch tasks. If the nest is attacked, workers might join the soldiers in defense. This flexibility allows the colony to respond dynamically to changing needs without waiting for orders from a central authority. It's all based on local cues. An ant might switch to foraging simply because it encounters more and more successful foragers returning with food. This brings us to a core principle: ant colonies function without a hierarchy. The idea of a queen as a ruler is a human projection. She is the reproductive heart of the colony, essential for its survival, but she doesn't govern. Order and efficiency emerge through cooperation and self-organization, not top-down control. This is a powerful concept. It means that complex systems can be incredibly effective without a boss. Every individual contributes by following simple rules and interacting with its neighbors. These local interactions are what create the global organization, a single ant bumping into another ant exchanging a chemical signal. Might seem insignificant, but multiply that by millions of interactions per minute, and you get a highly organized society. Foragers recruit others, nest builders coordinate their efforts, And the colony's temperature is regulated all through these small, local exchanges of information. Small, individual actions scale up to create large-scale, coordinated behavior. It's a bottom-up system, not a top-down one. One of the greatest strengths of this decentralized system is its incredible resilience. Think about what happens if a part of the colony is destroyed. If a predator attacks and wipes out hundreds of foragers, the colony doesn't collapse. There's no single point of failure. The remaining ants just keep doing what they do, responding to their local environment. Other ants will eventually take over the lost roles, new foraging paths will be established, and the colony carries on. This is a stark contrast to many human-designed systems, where the failure of a central server or leader can bring the entire operation to a standstill. The colony's survival doesn't depend on any single individual, not even the queen. While her loss would eventually doom the colony since no new members would be born, the existing workers would continue their tasks until the end. This remarkable structure, the decentralized system of an ant colony, is more than just a biological curiosity. It has become a powerful source of inspiration for human innovation. Scientists in fields like swarm robotics are designing groups of simple robots that can cooperate on complex tasks like search and rescue or construction without a central controller. Each robot follows basic rules, just like an ant. In artificial intelligence and computer science, algorithms inspired by ant colony optimization are used to solve complex problems, like finding the best routes for delivery trucks or managing telecommunications networks. The ant's method for finding the shortest path has been turned into a powerful computational tool. So, the next time you hear the term hive mind, remember that it's just a metaphor, not a reality. It's a convenient shorthand, but it hides the true genius of the ant colony. These societies are not single superorganisms with one mind. They are better understood as vast, dynamic networks of cooperating, decision-making individuals. The queen is not a monarch, and the workers are not mindless drones. They are all participants in one of nature's most successful and elegant solutions to the challenge of collective living. And what can we learn from this? The ant colony model offers profound lessons for our own organizations. From businesses to social movements, it shows that you can achieve incredible efficiency and adaptability by empowering individuals. Instead of relying on rigid, top-down hierarchies, we can create systems where people are given simple, clear rules and the autonomy to act on local information. When individuals are trusted to make decisions, and when cooperation is the foundation, organizations can become more resilient, more innovative, and more effective. The ants teach us that true strength doesn't always come from a powerful leader. Sometimes it comes from the collective intelligence of many, working together in a beautifully simple, decentralized dance. Thanks for watching. If you found this dive into the world of ants as fascinating as I do, don't forget to like this video and subscribe for more insights into the incredible designs of the natural world. See you next time.